Good afternoon. Everybody get their coffee and tea? No, nobody's going to sleep today, right? Okay, we're here for Zend Framework 2. I believe there's another talk. I'm not speaking in German. I don't know German. I'm sorry. But I'm very pleased to be here in Berlin for IPC this year, so thanks for having me. About me, I've actually been surprised. This is one of the first conferences I've walked around that I haven't had people trying to get my attention the whole time, which is kind of cool. My name's Weier O Phinney. My wife's name was Weier, and actually, as it turns out, they are from Germanic heritage, so it should be Weier, but we don't say that in the US. My Twitter handle is Weier O Phinney. I've been doing PHP since 2000. I've been doing other programming before that. My degree is not in computer science, although I started in computer science. I actually learned object-oriented programming in Perl first, so it's been a really interesting journey. I've been contributing to Zend Framework since January of 2006. It was announced as a project in October of 2005 at the first ZendCon. And of course, then we had an internal mandate to utilize Zend Framework within the company, and I was working on the CMS solution and backend services. So I started off doing actually an XML RPC server, and then gradually more and more until Andy asked me to be on the framework team. I've been leading the team since April of 2008. I've got 2 other developers on the team, so there's only 3 of us, believe it or not. But we are really an army of hundreds because of the number of contributors. I love open source. It's just one of those things I love. I feel really fortunate that I can do open source as my professional job, which is pretty cool. Zend Framework 2 has been a long time in coming. His first stable version of Zend Framework was July of 2007, and now we're coming up on July of 2012 in a little over a month here. And we realized, over the course of time that things could be better. The things that we're going to look at primarily right now, first off, PHP greater than or equal to 5.3. We want to use these new features. I wish we could say 5.4, but the fact of the matter is long-term solutions for most hosting providers and Linux distributions are going to be on 5.3 for a few years. A lot more flexibility. This was something a lot of people complained about, was it was really hard to hook into different parts of the workflow within Zend Framework 1. So we've got a lot of events, a lot of services, more performant. This is something that we were only able to prove in the last 3 weeks. But it is more performant at this point, now that DI is no longer the primary dependency injection mechanism. Open processes. This may seem like not a lot, but we no longer require a CLA. To give you an idea of how this impacted the project, we went from maybe a couple dozen contributors in the first year and a half of Zend Framework 2 to over 100 within the next 6 months. So this has actually been a huge thing. The other thing, of course, was we moved Zend Framework 2 development to Git and GitHub, which has facilitated just all sorts of contributions. We get everything from 1 or 2 character typo fixes to full features coming into the pull request queue. And having that easy, simple process that everybody's familiar with has benefited everybody tremendously. And diverse installation methods. Zend Framework 1, the only real installation method is downloading a tarball or a zip and taking that or using SVN externals. We have Pyrus support already, and that's per component, not just the project itself, but per component. Same thing with Composer. We just introduced that in beta 4. And of course, Git submodules if you're really daring and want to use Git subtree. This is kind of in a slide, a lot of the stuff that we're going to be bringing to the table. So when we look at Zend Framework 1, and we want to characterize it, I think of singletons and registries, hard-coded dependencies, soft dependencies, things that are coming out of your bootstrap that you're not actually declaring. It's a mess, and it seemed really great as we were developing it, but as time goes on, you see the limitations. It's hard to test, it's hard to do substitutions, it's very easy to get caught in this morass of where did this actually come into play, how did it get injected in the first place. As the F2 way, I would say event-driven services. And we're going to actually look at each of the pieces. Our new architectural approach is looking at solid principles, but specifically we're looking at a few types of paradigms. Decoupling, and we have two different tools for that, Zend DI and Zend Service Manager. We'll look at that in a few minutes. It's event-driven. We use the Event Manager a lot. When I say events here, I also mean things like signals, aspect-oriented programming. We kind of combined a bunch of different ideas into a single component here. We use a lot of SPL extensions. Our standard lib is primarily SPL extensions at this point. Working around some limitations, the heap implementation in SPL actually removes things, which is what it's supposed to do, but sometimes I want to iterate more than once. So we have things like that, or you want to serialize that sort of stuff. We're taking full advantage of PHP 5.3. The biggest backwards compatibility change is the very first one, namespaces. But that's actually a good thing because you can still use Zend Framework 1 code in Zend Framework 2 if you want to, because they don't conflict, even though we have ACL in both or authentication in both. We utilize Lambda functions and closure. So not a lot within the code, but we make it really easy for you to do it, which makes it easy for you to rapidly develop applications. You don't have to declare a new class or a new method or a new function in order to hook into the event system, for instance. You can just declare a quick closure right there and start doing things. This is particularly nice for debugging. I can go and tie into an event and just attach a listener that's a Lambda. Late static binding. This is one I never thought I would really enjoy, and I love it now. But there's some really cool things you can do with extension if you have late static binding available. Releases, we're currently at 2.0 beta 4. Our betas are more of a Gmail style. We're doing rolling features as we go until we get to a point where we feel stable. We're expecting a 2.0 beta 5 at the end of this coming month of June. Actually, it's June now. I wrote this last week, so at the end of June. And then a stable release by the end of the summer. Most of what we're doing for beta 5 is actually culling stuff that we don't feel is shippable for the stable release. MVC right now looks like it will for the stable release, so this is a great time to pick it up and test. So I talked that we have some architectural patterns that we're utilizing heavily, and what we have in particular is an idea of contract-oriented design. One of the problems with Zend Framework 1 was extensibility, because so many of the different things that you needed to do were extending off of other classes, sometimes nested 3 or 4 deep. It was hard to substitute if you needed to. So we decided that anywhere that we want to have a substitution, that we want people to have flexibility to do something else, we write an interface. So there's dozens, I think probably hundreds of interfaces right now in Zend Framework 2. And the idea is that anywhere that you want to use one of those interfaces, you can substitute another idea. To give an idea of how this worked, we were trying to evaluate what the performance of Zend Framework 2 was. And it was hard to evaluate because Zend DI uses reflection by default. It's possible to create your own definitions and compile definitions and everything, but by default it uses a runtime definition. And as a result, we were seeing not great performance. However, we were utilizing an interface for where the dependency injector came in. So Evan Corey, one of our developers from the community, went and created an implementation of that interface that basically was a big service locator, but it was all programmatic. So we were able to eliminate a DI entirely from the results, and we could see what the true performance of the application framework was because we were able to do the substitutions. So part of that, of course, is favoring composition over inheritance. So instead of us having these huge inheritance tree, we now have a few implementations of a particular thing. And of course, that means that we have to do dependency injection of some sort. Another thing about the interfaces, it allows us to focus on what is the core message, what are the core concerns we want to do in Zend Framework 2. It was really easy in Zend Framework 1 for somebody to come up and say, I'd like this feature. And me to say, oh, that sounds really cool, and go and implement it, and then discover it broke 2 other features we'd already implemented. So now instead, I might actually say to you, that sounds really cool. Why don't you implement it yourself? And then you can put it in. But that means it's going to be a more stable framework for everybody else. And that's really the goal that we're looking for here. So dependency injection, how many are not familiar with dependency injection or haven't used it much? Nobody. This is good. Oh, a few, okay. So this is a little bit of rudimentary stuff for most of you, but in a nutshell, we show 2 different kinds here. We've got required dependencies through the constructor on line 7, and then, of course, optional dependencies through setter injection on line 8. So baz is new baz with foo, and then we say set bar, new bar. So this is dependency injection. It's just passing an object in. Typically, you will type hint so that you can enforce a contract. Zend is a dependency injection container, and it's a slightly different beast. Back here, we all know how to write this. The container we configure. So we have a number of injection patterns that we support, constructors and setters, obviously. Interface injection is a fun one. If you create an aware interface, it will automatically try and inject. We can also do annotations and a number of other things. Basically, you manage dependencies through configuration and annotation. The annotation is optional. You don't have to use it. If it's there, it will utilize it. And in fact, I think there's a flag so you can tell it whether or not you want to. We also provide a compiler so that you can point it to a set of classes, and it will go and figure out what the definitions are and cache them for you in a way that you can then feed into the DI container. So sample definition looks something like this. So we're defining class baz. So this is for that same example we had here. We're going to define a definition for it. Now, we don't typically want to do this, and actually Zend does a really good job of auto-discovering this, but this is what it would compile it down to. We've got a constructor that has a foo argument that is of type foo, the class foo, and it's required. Set bar, when I say required here, at the method level, we're saying that it's required injection, so when I pull this out, it has to have this. By default, setters will not be that way unless you tell the compiler to do so. We've got a bar parameter, and it's of type bar, and of course it's required if we call that method. So this is what it looks like. This is a lot of code. I don't want to write these, and that's why we have a compiler for it. But using the container is pretty simple. We go and we grab the configuration, so we can configure definitions, instances, and there's like 2 other parameters you use. Definition and instance were the ones I use most often. We say our class definition, and we give our definition there. And we configure the DI container, and then we grab baz out of it, and we'll have foo and bar at that point. Actually, that should be bar, shouldn't it? Yep. Oh, well. Anyway, we grab it, and it's all fully instantiated. Now, for a simple example like this, it doesn't make any sense. But when you start thinking about why we looked at DI, it does. The reason that we started looking at DI in the first place is how do you get resources into the controllers that you use? How do you do it in Zend Framework 1? Anybody here using Zend Framework 1? Okay. Randomly, just shout it out. How do you get, like, say, for instance, a database connection into your controller? Yes, okay, I'm hearing 4 or 5 different answers out there. Right, that's the problem. And so that's what we're trying to answer is how do I get that into there? Well, if I define a setter for it and I have a definition for it in the container, I can pull my controller as a service out of the container, and it's fully configured with all of its dependencies. That's simpler, because then I don't have to worry about how I get it. I just know it's there. So we have a bunch of use cases here. We support annotation-based injections, interface injections. All the use cases are captured, which is great. Ralph Schindler, also of Germanic descent. He did most of the DI stuff, and so he compiled all the use cases in this project called ZF2 DI use cases. So if you want to see all the different ones, you can go there. I think there's like 26 different ones in there right now. You can see how you can configure the container, how you can do all these different pieces. Now, that said, Zend DI, I mentioned before that it uses reflection by default, so it tends to be slow. And it's a limitation of using reflection. Now, like I said, you can compile them, but that introduces a step. When you're doing development, that means you either have to compile each time or you need to fall back to runtime. And quite often, you'll forget to compile when it goes to production. The other thing is the container, configuring the container is a bit difficult to learn. While it has a very regular format, since there are so many different use cases, it becomes a little problematic. If you wanted, for instance, inject the same method several times with different objects, difficult. If you want to say that these setters are required but these aren't, difficult. So it's difficult that way. The other thing is debugging is hard. You'll get back a cryptic message saying, hey, I wasn't able to get it out of the container, and it might be for an object you didn't even know you were trying to retrieve. And all you get is this tree, and even Xdebug sometimes can't make good sense of it as to what you're actually trying to get. So we started looking at this and said, DI is fantastic. We love the concept of DI, but we need something faster and easier to educate people with. So we came up with the Service Manager. Service Manager is very fast because there's no magic or discovery. It's just code. You write the code for it. You code and configure your injections. When I say configure, in this case, you'll have the configuration right there, which is fantastic. It's all explicit, which makes the debugging simpler because when there's a problem, you'll find the problem. It will, your fatal errors are pointing to your factory or whatever, where you're defining all this. There are a number of different types of services that the Service Manager is able to understand. We've got explicit ones where you say, hey, I'm going to put this object in the container, and that's easy. I'm going to go through all of these in a minute here. You have invocables where you simply say, hey, when you pull this service, give me an instance of this class. And so you give just a class name. Factories, you say, when I pull this service, here's a factory, and it can be any sort of PHP callback. Any callback works. We have a factory interface, in which case it will call that particular method, but any callback. So this is great. You can actually do a Lambda or a closure within your module classes to do this. You can alias. So when I pull this service instead. Abstract factories. If you want to handle arbitrary classes, maybe they follow a certain pattern like controllers, for instance, you could do an abstract factory that will do that. We actually use an abstract factory to fall back to DI so that if you are pulling a class name and that class exists, it will actually try and pull it out of the DI container at that point if there's no service name associated. Scoped containers. Basically where you want to limit what can be created and give a little bit more logic around it. We use a scoped container for pulling controllers actually as services, and that's mainly to ensure that we don't try and pull just an arbitrary object. And then you can decide whether or not an instance is shared. So look at each of these. The first one is the simplest, a service. So I say, whoa, that's the shared one. That's the wrong one. We'll skip that one. What we would say here actually is when we say we'd say services up here, and we'd say event manager, and we'd give it, I'd say like new event manager right there. I cut and pasted incorrectly earlier. Invocables, this is the easiest one. We say foo is going to be some component foo, and so we'll instantiate that. Since instances are shared by default, it will instantiate it once, and then any other time I call it, it will give back that particular instance. Factories. Factories get the service manager as their sole argument, so you can actually pull things out of there. And I'm not actually doing it here, but for instance, I could pull another dependency out and inject it into the constructor here. So factories are really great when you need to actually do a little bit of work to get your instance. You can use any callback, so use the very first one for foo, I'm using just a closure right there. For bar, I'm specifying a static method, so I can use a static method if I want to. That's great for a factory, for instance. Or I can do a class implementing the factory interface, so a Zend Service Manager factory interface. If I implement that, it will see that and call it correctly. Aliasing, I can alias to an existing service, so that's the first one on line 19 there. Line 20, I'm aliasing to another alias. So you can actually do this. We do some circular dependency detection and making sure that that doesn't end up messing up your code more. But that's actually really useful. I use that, for instance, the ZFC user module uses an alias to point to the database adapter and also do the authentication service. So I can actually pull that and actually have aliases of my own. Yep.
Is there a mechanism to detect circles in there?
Detect what?
Circles?
Yeah. Yep. Yeah, we don't want that to happen. Yes, yeah, circular reference detection is built into there. Abstract factory. This is what the abstract factory interface looks like, basically. Can I create a service with this particular name? And then create the service with the name, in which case you get the service manager and then the name passed to it, and you try and create it. As I said before, we have an abstract DI factory that will use the DI container that you configure in order to do to pull something out that way. So if you want to use DI, you can. And you can also say shared services, but typically everything is shared by default. So if I don't want something shared, I pass a false value here. This is a good example of one. We wanted an event manager instance per class that requested one, and then a shared manager injected into that. Then that one's going to be shared. So the event manager, we had to say, no, do not share. So the fun part about the service manager is you can configure in a lot of different places and override configuration and override some of the definitions very easily. So you can do it at the application before you bootstrap anything. You can do it in your module classes. You can specify configuration for the service manager. The module configuration can do it, and you can also do local override configuration. So there's a variety of places you can do it. You can use aliasing. You can override. And what we found is it's very fast and it's very intuitive. We had some people playing with it with the Zend Server UI team who were comparing DI to Voodoo and using the Force. And now they like the Service Manager because it's very easy for them to understand and debug. So this is one of the core patterns is dependency injection. How do I get my dependencies into my controller? And we use services for this. Another thing to note is our plugin broker is service locator aware, so it will get the service manager instance. So it makes it really easy to have plugins that need dependencies. So view helpers, your controller plugins, that sort of thing. You can pull those out and they'll have their dependencies when you pull them. So I mentioned event-driven services, and we talked about services now, but let's talk about the event manager. Who doesn't do JavaScript in here? Nobody's going to raise their hand, right? Well, who has never seen JavaScript? Shut up, Derek. So we've all done JavaScript. Who has? We all know what events are, right? Right? Who has not triggered an event or registered an event listener at some point? Right? We all have. The event manager is analogous to that. We trigger an event and then we listen and react to triggered events. So we have an event manager, which handles assigning listeners to the specific signals, and then it triggers them. And you will compose an event manager in an object, and so that you can trigger events from your object. So we aggregate those. The listener in Zend Framework 2 are simply any PHP callback. So it can be it can be a closure, it could be a static method, it could be a typical array callback of some sort. Anything that is callable can be used. Listener simply reacts to an event, so it gets the event as its sole argument, and it's able to pull parameters out of there, know what the target, what triggered the event, and that sort of thing. The event is simply an action. It's just a name, really. So I say trigger something, and it then figures out what listeners are attached. This is the simplest example. I'm attaching a closure here to the do event, and you can see I can get the parameters and the event name, and I'm just going to print that off, and I'm good to go. You'll notice here the null part, this is because there's no target. Normally I'm doing the event manager within an object, in which case I will pass $this there, at which point when I go into here I can say eGet target, and I'll have that object instance, so I can figure out the context in which I was called. But then I get past parameters. This is a very simple one. Typically, we actually have context-specific events. So the MVC has an MVC event. The view has a view event that have some contextual setters and getters so that you can say, I want to get the application instance or the router or the route matches, and I can grab those out of the event so that we have this context that's shared throughout. There's a lot of pieces that we have. I mentioned earlier the shared manager. We can attach here to a specific instance of an event manager. The shared event manager allows us to say, hey, I may not have an instance of this particular class, but once there is one, it can listen in on here and pull events out of me, event listeners out of me in order to trigger them. This may seem like, well, why would you want to do that? But it's tremendously useful. For instance, during bootstrapping, you may know that certain objects may sometimes be at play, but you don't know if it'll actually be triggered in this particular context. Perhaps we'll have an error at some point, and perhaps we won't. But if we do, it'll get triggered, which is really nice. We have wildcard attachment, so you don't have to necessarily know the name of the event. You can use wildcards in here. Short circuiting, both from within an event, so you can say stop propagation, some sort of a weird thing happened here, we should stop. Or you can have some sort of rule, and we define the rules as closures or as callbacks, and you can say, evaluate the return value from a particular listener and decide if we need to stop. We use this in the MVC, for instance. If we get a response at any time, we short circuit and we exit back out and return that response. The other part is because we have access to the responses, we do aggregate the responses so that if you want to, you can go and aggregate through those and react to them if you want. So far we've been talking about patterns. So it seems like, why are you doing all this? Well, let's take a look at the MVC. The MVC is really, it's all event driven. And so you have these services and you've got these listeners. Bootstrapping is an event, routing is an event, dispatching is an event, rendering the view is an event, finishing the request is an event. And so you can have arbitrary numbers of listeners on any one of them. I forgot to mention, we also have priority within the event manager, so you can figure out exactly where you want it in the queue. So when it comes to the MVC, we've talked about two of the core concepts, and that's events and services. The third one is controllers. So events, everything's an event. And these are like the main events that we have in the system. You can define your own events as well. But we have, for loading the modules, and we'll talk about modules in a minute here, but pre and post loading all the modules and loading an individual module, we can do things. Bootstrap route, dispatch, and dispatch error. If we have some sort of error that occurs, we dispatch something separate so we can figure out how to handle that error. And then rendering and finish. For services, we have the service manager. And we talked about this. The biggest thing, though, is this last point. Controllers are services. Yes, you can inject the service locator into the controllers and lazily pull stuff out. Don't do it. Get your dependencies injected by the service manager. Create factories, so that you can do this. Basically, you're providing services. You're providing controllers that are going to listen in and do some things, to do some work of some sort. And your controllers are what are called dispatchables. Basically, we're doing HTTP, right? We have a request coming in and we want to deliver a response back out. A dispatchable takes the request, also a response object, so that we have a shared piece here, and we return that response object back out so we know what to do with it. We're just doing HTTP negotiation, so that's all we're doing. Controllers can be really simple. The default controllers we have actually have a lot of stuff going on. There's event management, there's aggregating a service manager, we aggregate a plugin broker. There's a lot of stuff, and it's for your convenience. However, to give an example, in my own website, I have a page controller. I know that certain routes are going to come in, and I just want them to go to a certain view script. All I did was I implemented the dispatchable interface, which is dispatch request response, and I return a response. So I'm able to go in there and say, do I have a view script that corresponds? If so, return my view model, and I'm done. So I was able to do something very simple. You can do simple, you can do complex, but that's all a controller is. So now we get into the true quick start, and that's the Zend skeleton application. How many of you use Zend tool? Okay, it's gone. We may introduce tooling eventually again. We have somebody working on a console component, and we're looking at some stuff with tooling. But we started looking and saying, hey, we want people to start using the MVC right away, and we want to give them an easy way. So we have the skeleton application. Most likely, Zend tool will use the skeleton application to get you started. You can grab the skeleton application really easily. You clone the skeleton application off of GitHub, you go into it. We use Composer. We actually have the composer.far file in there, so you just say php composer.far install. It grabs Zend Framework for you, and then you point your vhost at it, and you're good to go. It's good to start. So it gives you everything to go right off the bat. Now the folders tree, we have a few things right off the bat. There's config, data, module, public, and vendor. I'm going to go through them in order, except for module will be last. Config folder has autoload, and these are your local overrides. So with that, we can glob things. That's why it's called autoload, because we use a glob pattern in order to go through them. And what we've decided is we're no longer going to use environments within the configs. Instead, you define your environments by having different configurations and establishing a different glob pattern. So the default one is global, local. So your global ones will probably go into version control. The local ones you'll have somewhere else, and you'll glob them in and be able to go from there. But that's in there. Now the application config is actually relatively short, because at the beginning of the application, we really just want to know how are we going to get our controllers. So we'll do that through modules. And is there any default configuration we need for the service manager? We're not going to talk about these too much, other than you'll notice that we have two directories that we've already seen, module and vendor, in here. And those will be the default paths that we're going to look at for modules. And then we activate modules explicitly. Well, there's no automagic anything here. We want to explicitly say, I want the application module. If I add other ones, I'm going to explicitly add them in there. Data folder is going to be for web data of some sort. It could be uploads. It could be your caching stuff. And there's all sorts of things. Public, of course, is the document root. We have our index.php, our htaccess, any assets, that sort of stuff. Boring. Vendor folder. Now, I say Zend Framework here. If you use Composer, it will actually go to Zend Framework /Zend Framework, all lowercase. Composer uses the package name as a hierarchy, so it's kind of strange. Regardless, since if you grab the skeleton application, it will find it, so it will find there. If you install other things through Composer or through Pyrus, these are your vendor libraries. You're going to put them in here. That's stuff that you don't want to touch. Typically stuff you don't want even in your version control, because you'll re-implement that, have a deploy hook or something that pulls that in. But modules are interesting. I like modules. Our module folder, actually, I'm just going to define a module first, and we'll go back to that. A module is all related code and assets that relate to a specific problem. You're not going to put your entire application in a single folder anymore. If you're writing a contact form, write a module and have that module have the controller, any validation, any form stuff that you want to do in that particular module. I've already written one, so you don't have to. If you're going to write user authentication, write it as a module. And in fact, somebody already has. We have a ZF Commons organization on GitHub now, and they're trying to create high-quality modules for you. ZFC user has very basic stuff. It hooks into ZendDB, but they also have some extensions that are further modules that extend modules for using Doctrine ORM, the Doctrine ORM or Doctrine ODM. And I believe there's also one for GitHub's OAuth system. The point is that you group the related code in one place. Because of the service manager and the event system, you can pull these, use these in other modules or in your application area very easily. So you want to have it self-contained. That makes it easier for you to maintain. It makes it easier to reuse. It makes it easier to test because you're only testing that specific functionality. The module is basically just a single directory, and you'll have this module.php in there. It's a class in that namespace. If I were in a different one, like fly contact, that would be my module name, and I'd have a class, fly contact module. That module class is an empty class by default. You can define some behavior that we have listeners in the module loader that will go and do things. Some default ones, and I'll show you in a minute, are things like grabbing autoloader configuration so that it knows about the classes that you've defined. Grabbing configurations, so if you have configuration that's specific, like view paths, helpers that you want to define, services that you want to define, it will do that. You can even define services in your module, so if you're doing things like closures for factories, you can do that. Very simple structure. The recommended structure we use, we have config, and that's where your module-specific configuration goes. Source for the PHP code, view for the view code. I also quite often have a public directory for assets that are specific to that module. So for instance, if I have any images or CSS or JavaScript. In fact, the default application one does. It uses Twitter Bootstrap, so it has some JavaScript and CSS assets. So this is what it looks like. The basic goal of a module, though, is to inform the MVC of services, which include your controllers, so that it knows what it can do. So you want to tell it, how do I route to specific controllers? Here are the controllers that I know of, and here are any services that are related to it. They're supposed to be plug and play. And I'm doing a full-day workshop at DPC on Thursday, Dutch PHP conference. And the first two things I do is I'm installing a contact form and ZFC user. And it's really, I drop them in, and I do a little configuration. And that's all there is to it. It's really quite nice. Once we do that, the modules are simple. It's a namespace, and you have a module class file. You should be developing modules. The entities that are for a specific problem go into there. Plugins go into there. 99% of the time, you're going to be doing this. You'll have things that are specific to your application and your application module, or some things you might have a few modules that are really you're never going to reuse. But most of the time, you're going to still be doing modules, and that's because this is it's a self-contained piece of functionality that has all the different concerns that you're interested in. Now, this module PHP, like I said here, we've got our autoloader config. We're going to do a class map autoloader and standard autoloader with our namespace. Our configuration will grab that config module.config.php. This stuff is really easy. You can also say, I want to tie into the bootstrap. I want to do certain things when the bootstrap event is triggered. You can do service manager configuration. As it loops through, it'll see that it has service manager configuration and pull that from that method. And there's a few other listeners that we do as well. I talked about the other thing. We've got, we need to inform it of controllers and stuff. Part of that's going to be our configuration. So we want to configure our router. Our router is really fun. We've got about 7 or 8 different route types that you can do, ranging from regular expressions to host names to segment routes to literal routes like this one. And really all you're doing is you define some configuration in there. In this case, we have controller in action. Never use that one. Always write an explicit one. And I go through this on Thursday, unfortunately. You can do literal routes. Another thing that you can do is you can nest the routes. So you can have child routes, and so you can define something. So one of the recommendations I have is that you have a top-level module route and then child routes underneath it, so that you can change, like the namespace on the URL system that you utilize for that particular controller, or rather module. Besides the routes, then of course, we said in here that we're going to use the go to an index controller. So now we need to define the index service. You'll notice here that we have this separated. This is because the controller stuff is a scoped container. So we're going to say that the index one is going to go to that particular index controller. We can do both classes and factories. Classes are like invocables, and then factories if you need to do any sort of DI. Really easy. And then there's some other pieces. We've looked at router and controller. View manager. Typically you'll only be looking at the template maps and template path stacks, and perhaps helpers. In the application one, we have a lot more because we want to set up things like how we display 404s, how we display error pages, the doc type. You can set the base path here if you want to. So if you're going to be under a, within the same vhost as another application, you can do that. So these are some of the typical ones you'll see. The index controller looks a lot like what we had in ZF1, because you're simply going to append action to the controllers that you're going to use, to the actions that you want to use, and then controller there. It's very similar. One piece that's different, though, is that there's no view rendering right off the bat. View rendering happens at the very end. You can return a view model here, though. And what the view model does is it tells me, okay, here's the template I want to use. Here are any variables I want to use in rendering. There's a view model in the event that represents the layout, and this gets then injected into that. We have a number of listeners by default that will do things like auto-populate the template if you didn't do it yourself. If you return an array, it will create a view model for you and inject that into the layout view model as well. You can also tell it what variable you want to capture it to in the layout, so that if you want to say this is going to be the sidebar, you could capture it to the sidebar variable in the layout and say capture to. So this is one thing that's very different. We don't render until the very end. That actually gives us a whole bunch of different things that we can do. For instance, if I want to do JSON or something like that, I can have a rendering strategy that says, hey, the accept header says that I want JSON back, so now we're going to use the JSON renderer at this point. I'm not going to go into all that because this is supposed to be a quick start. So this is it, really. Most of the stuff that you're going to be doing is you're going to create a module. And so you'll create this directory structure. We actually have a skeleton module that you can do that has this entire directory structure and some sample assets and configuration for you. And you create some controllers, you create some routing configuration, and you tell the application that here's my module and you're good to go. So you have a question?
Yeah. What about common files? For example, models or common classes that I want to use all modules?
So you can still use libraries. You can put those in the vendor area. You can even have a library within there. There's nothing saying you can't use that. And in fact, you can specify, in your application module, you can say, I also want to add this autoloader configuration, and so it will go and look in that directory for those things. The other thing you can do, I've done this with some of my stuff. I know that I'm using the same classes over and over again. I've actually created a module that has that, and then I drop that in. And it's just code in there. There's no MVC stuff, but there's models and interfaces and stuff that I'm going to be using over and over again.
And if I define services for service manager in this module,
Mm-hmm.
it will be available for all?
Exactly. Yep, you got it. So skip forward a bit here. So was there another question over here? I thought I saw a hand. No? Okay. Packaging options. How do you get Zend Framework 2? First off, the packages.zendframework.com, you can see that URL in the top line here. That's where all the packages for Zend Framework 2 are right now. That web server is also a Pair 2 channel server, and it also has the Pair 2 installer called Pyrus available for you. So you can grab it, you can use wget to get the pyrus.far. You say pyrus.far vendor directory, and then we say we want to channel discover packages.zendframework.com, and then I'm going to install the entire framework. That's what line 4 is. Or if I wanted to do a single component, I can say like ZF2 Zendlog. So we can have per component installation. So if there's just a few that you want to do, you can do it through Pyrus. Pyrus is really cool. I had a lot of hope for it, but it's stalled a lot, and the reason being that the lead developers are both really busy, which makes sense. They're well employed. So the other fun thing that we added with Beta 4 is Composer support. How many of you here know Composer at this point? A lot of you. So for those of you who don't know, Composer, a few guys got together and said, hey, we don't like package management in PHP. We need, Pyrus is okay, Pair is okay, but it's not great, and we want to make it easier. They were inspired by the Node package manager. They looked at Red Hat and apt-get and stuff like that, and they tried to figure out a way that we could do it. It's a really nice tool. Packages.org has a list of different packages, and it's also a place where you can register packages if you want. And then Get Composer is where you actually get the binary. Basically what you do is you tell it, and most of the time you just say require, but if you have an additional repository, which we define one with packages.zendframework.com, so we say it's a Composer repository and we give it the URL to it. And it will then know where to find our package information. And then you say, I want to require, if you say Zend Framework, you actually don't need the repository because that will go to GitHub. But if you want an individual package, you can say something like Zend Framework/Zendlog and tell it a specific version or range of versions. You can even say asterisk for any version, and it will go and grab that package for you. And the way it does it is you grab the installer, and then you say install. What's cool about this is you can actually keep the stuff outside of your version control. What this says is that when you install it the first time, it creates a composer.lock and says this is the version that was installed, and you put that in version control. Then in your deployment phase, you can go and say Composer update, and it will see that Composer lock, grab the files for you, and install them for you. So this is a really nice tool. So this is another option for you. We also have some zip and tarballs of both the full framework with tests and everything, as well as a minimal version for those of you who really want to go that way. But these are the two easiest ways. I can get a skeleton application up and running in like a minute and a half at this point. And it's fantastic. We're running close to time here, so I'm going to talk about contributions. I told you earlier the betas are kind of a rolling feature, like Gmail style. So we're getting towards the end of that cycle, and we really need people to test. There are a lot of ways you can contribute. Our contribution is all up on GitHub. We have a mailing list and everything. I'll give you URLs for that in a minute. But what we need you to do is write code, write documentation, write tests, test it yourself, and give us feedback. Most feedback these days is actually coming in the form of pull requests, which I think is the best way possible. So basically, if you run across something and it doesn't work for you, give a pull request. It can even be a pull request simply stating, here's a test showing my problem. And we'll take that and say, okay, now we have a failing test, and Travis CI is complaining at us, so we're going to go and fix it. So this is a good thing. But go and download it. Start building applications. Build modules off of it. See what works and what doesn't, and get back to us. Our main area is we have a subsite within the framework.zend.com/ZF2 that has links to our mailing list. It has links to the bug tracker. It has links to GitHub. We use Agile Zend now to manage our releases. So you can, we have a board that's pulled from the API, but you can also register with Agile Zend, and it shows you how, so that you can look at the board and see where you can help. So you can see stuff that's stuck in the ready phase, or it's a work in progress, but clearly it hasn't been updated in 21 days. You can go and then contact the developer for that. We have weekly IRC meetings. Normally it would be about 2 or 3 hours from now. It's on Wednesday, or no, tomorrow. It's on Wednesdays at 800 UTC. Zend ZF2 meeting on Freenode. We publish the agendas usually a day or two ahead of time, so you can see if there's something you're interested in. If you have a subject you want to bring up and there's not an agenda, create one and add it. And then ZF Talk 2 is our main IRC channel on Freenode, and there's always people in there. You'll see a few people that seem to be there 24/7. Evan Corey is one of those. Don't do what he does. He's doing some sort of dysphasic sleep pattern. And sleeps for like 4 hours a day. It's crazy. It's like 20-minute naps for every 4 hours. So he seems like he's on there all the time, and he is. And we've got a few other people trying it out, which is endlessly funny. But yeah, go in there if you have questions or if you want to contribute. People will point you to stuff that you can do. Feedback for this talk is on Joined In. If you haven't gone there already, start rating talks that you've seen. Direct feedback, there's my email address, and my Twitter handle is Weier O Phinney. Are there any last questions before we're done? Any pending things that people were interested in? Okay. I think we're actually technically overtime. I show 50 minutes on here. So thanks for coming. I hope you enjoy the rest of the conference. And try out Zend Framework 2, please. Thanks.